Okay, this whiteboard problem is 26.7, and the question says two capacitors of 2 and 4 microfarad capacitance are connected in parallel across a 300-volt potential difference. And part A is calculate the total energy stored in the capacitors, and B is calculate the charge stored on each capacitor. Okay, so let's do our givens and finds. So I have given, say C1 is equal to 2 microfarads, C2 is equal to 4 microfarads, and the potential, V, is equal to 300 volts. And we have to find the potential energy and the charge. Okay, so let's do A first, the potential energy. So we know that the potential energy is equal to, there's three formulas that we can use, and we're going to use the one 1/2 C times V squared. And the reason we're going to use that is because we're given C for each of the capacitors, and we know the potential. So it's an obvious equation to pick. And now I'm going to draw my, my picture. So I'll draw that over here. So I have a capacitor here. Notice the lines are equal in length. And I have another capacitor here. They're in parallel. And they're both connected to a potential difference of 300 volts. So I'm just going to draw it like it's a battery. So this is going to be 300 volts. And let's say this is C1. So C1 is going to be 2 microfarads. And this one's going to be 4 microfarads. Okay, and I want to, when I combine this, I want to redraw it so that I end up with something that looks like this capacitor. And I'll call this capacitor CEQ for equivalent capacitor. And I'm going to connect this to my battery. And so what I want to do is find CEQ. So when I have capacitors in parallel, I know that CEQ is equal to C1 plus C2. So in this example, that's just 2 microfarads plus 4 microfarads. So that's just 6 microfarads. So CEQ is equal to 6 microfarads. So I'm going to make this equal to, move this over a little bit. This is equal to 6 microfarads. Okay, so, and this is also equal to 300 volts. So I just need to plug this into my equation over here for the potential energy. So the potential energy then of stored in the capacitors is equal to 1/2 times CEQ times V squared, and that's just equal to 1/2 times 6 times 10 to the minus 6 farads times 300 volts squared. And so PE, so PE then, when I multiply through, I get 0.27 joules. So that's part A. And now part B says calculate the charge stored on each of the capacitors. Okay, so in this case, the charge stored on each capacitor, let's see, move this down a little bit. This is going to be B. I'm looking for Q is equal to C times V. And let's see, this is asking me the charge stored on each capacitor. So for Q1, I'm going to have C1 times V, and that's going to give me, C1 is 2 times 10 to the minus 6 farads times 300 volts, and Q2 is equal to C2 times V, and that's equal to 4 times 10 to the minus 6 farads times 300 volts. So just plugging that in, let's see. So plugging that in, I have, let's see, 2 e to the 6 times 300. I get, so Q1, let's move this down. So Q1 is equal to 6 times 10 to the minus 4 coulombs, and Q2 then is equal to 12 times 10 to the minus 4 coulombs, just double.